quantum computers. In developing the computer system of the subspace, I used a quantum computer principle of the trinary logic. Now, quantum computers are computers that are beyond the binary on or off and use a trinary on, off, or maybe, a quantum system.
So if you can control individual qubits, you have an amazing clock. But if you can scale up and control the interactions of dozens or hundreds of qubits all at the same time, you don't just have a bigger quantum clock. You create a quantum computer, which has the potential to be the most important invention of our time.
Quantum mechanics explains a great deal, like why hydrogen in a star emits a certain frequency of light. But it also describes some weird situations. For instance, quantum mechanics proves it's possible for a particle's spin to be in two states simultaneously, up and down. If you measure the spin, you get an answer, up or down. But if you don't, then the particle acts as if it were in a combination of both the states at the same time. This combo trait is called superposition, and it's kind of like my broken sink. Maybe I'll fix it myself. Maybe I'll call a plumber. I could go either way. But ask me one more time, and then, fine, I'll call a plumber. Are you happy now? See, by asking, you forced me into a state, dear.
And that brings us to animal cruelty. Regarding superposition, Erwin Schrödinger said the same thing we all did. WTF. But more eloquently, using a thought experiment, he proposed sealing a cat in a box with a mechanism that would either kill the cat with cyanide gas or not, depending on the particle's state. Schrödinger said that with the box closed, the state of the particle can't be observed and therefore exists in both states, concluding that the cat simultaneously exists both alive and dead. Spooky. But wait, can't the cat measure the state of the atom, thereby forcing it into one state or the other? Well, that's the point of the paradox.
And that brings us to qubits, or quantum bits. In a classical computer, information is stored in bits, which are either 0 or 1. But in quantum computers, we use particle spin that could be simultaneously 0 and 1. As long as we don't measure the spin, the particle is in both the happy cat and zombie cat states. With classical bits, 3 bits are combined sequentially to make a total of 8 states, but 3 qubits can make all 8 states at once. Now imagine a computer with hundreds or thousands of qubits. That system is so complex, it can't be modeled by a classical system. So where is quantum computing today? Canadian firm D-Wave has a device that they claim is a quantum computer, though experts remain skeptical. The D-Wave 1, which comes with a refrigeration unit to cool the qubits down to an amazing 20 millikelvins, has been used by Google to research a super fast way to search images using Grover's algorithm. And another was sold to Lockheed Martin for undisclosed purposes. Other machines are being researched, the most promising ones using trapped ions manipulated by lasers. The research is ongoing for both the algorithms and the hardware, and frankly, it's starting to feel like the Arrested Development movie, always just a few years away.
Well, I don't know about Arrested Development, but in 1996 I made a quantum computer system from the software using indeterminacy, uncertainty, entwinement for the basic quantum principles. I made the system for the new Eductor, and instead of using quantum hardware, I made a quantum logic software, trinary quantum logic software, so I could use human entwinement and entanglement. I called it QXCI SCIO, now the Eductor.
If you think superposition is weird, get a load of entanglement. It's possible to link 2 particles to the same quantum state and make them entangled. Then you can separate the particles, and whatever action you perform on one of the particles instantaneously happens on the other. This means quantum information travels faster than the speed of light. Also, it can't be intercepted. Einstein called this spooky action at a distance, and he didn't believe it would work. Whatevs. I say, if you want to give your armies on Mars the attack signal without the Klingons hearing you, give them a set of entangled particles before they leave. Take that, radio communication and Navajo wind talkers!
Now these entwined, entangled photons are used to secure money and many other different things. They have come into science, and quantum computers involve indeterminacy entwinement as a quantum principle.
Very important fundamental thesis in computer science called the modern Church-Turing thesis. And what it says is that all regular classical computers are essentially equivalent. It's not that they exactly perform with the same speed, but they act according to the same rules, they behave similarly, and if you try to perform some task with, say, your laptop, and then you try to do the same thing with another computer, it will sort of behave approximately in the same way. Quantum computation, it just is completely out there, out of this equivalent class.
Quantum computers are based on the fact that the quantum state of a computer memory contains much more information than its classical description.
A quantum computer will also be different in that it will manipulate and store quantum bits instead of classical bits. Classical bits can be in two states, 0, 1. Quantum bits can be in many possible states. And this new range of possibilities lead to new phenomena such as entanglement and interference. And we believe that this is what can give a quantum computer its power, these new phenomena.
Yes, entanglement, the idea that particles once together will keep an informational base between them. Entanglement. We have the idea that this happens throughout the entire universe because it was proved through Bell's theorem that once items had gone through the Big Bang, there was a leftover information sharing, an idea of a new space-time quantum worldview. Very interesting. This gave us the idea and a balance, and I was able to put this into operations with the SCIO. You see, there's an infinitesimal universe that's entwined and entangled, and at one level of subspace. There's no such thing as noise, only information that we don't understand. This is a quote from me, Desiree Dubonnet. You see, I was able to prove that the actual cleft, the synaptic cleft of the brain, was a quantic event by putting all the different mathematics into the equation. And here we were able to show that the human brain works as a quantum computer. Now, could I put this same type of indeterminacy and put a trinary type of qubit computer into the software? Having done this and shown this in books back in 1986, I was able to put this together into a system that would show just why certain things are yes, no, and maybe, the trinary logic. And this trinary computer logic, off, on, maybe, or the I Ching, would involve an indeterminacy. I see God had a random number generator, and to give us all free will. See, God is the dice. And computers do not make true random numbers. You see, they make it from the timer chip. It's not true. So I had to make a whole patented operation, a secret operation, to make a true, real random number generator that didn't exist in the computer. And I used a type of a Gumbel distribution, but it didn't work, and I had to expand on it with different increments to make a true random number generator to be able to do the subspace connectiveness and to make a quantum computer system, which I was able to finish in the QXCI in 1996, making possible a subspace entwinement process. And this has become the most research energetic medicine device in the history of the world. The QXCI were the first operative true computer systems in the world today. I was able to develop this in the software, not the hardware, of the SCIO, QXCI, and the SCIO, and later the Eductor, to be able to use this trinary system in the logic. This trinary system will then take over if there is a loss of the 0 and 1s, the binary system, from the electrical measures. This is how the subspace system works. Keep in mind that the SCIO and the Eductor are very strong electrical factors, and that it is only when those electrical readings are not there that the system then goes into total subspace. The United States Navy had built submarines with quantum computers, and they did everything very well. But they wouldn't fire missiles. They wouldn't arm the weapons. So perhaps this quantum principle in the quantum computers allows in a type of God consciousness. Perhaps that's the way. But in order to stabilize that with our system, we built in the Tibetan prayer wheel that we've discussed before. You see, in 1996, I made a quantum computer system using the indeterminacy entwinement quantum principles. This entwinement was a subspace connection, and it acted like the human consciousness, bringing a type of human consciousness to the computer. But the prayer wheel was there as an inanimate object that had the ability to pray. And since all things are connected at some quantum level, the prayer wheel could stabilize that quantum subspace system. And I became one of the leading experts in the field.
Biologists, all these things are really important. The chemistry of atoms, the behavior of materials all depend on quantum mechanics, and a quantum computer is really good at simulating that.
Others foresee a different role for quantum technologies.
Quantum mechanics is now giving us the tools to sense things better than we've ever sensed them before. We can sense mercury in fish. We can sense lead in toys. We could perhaps sense bombs along the side of the road. Using quantum mechanics, we can make the sensors more robust, more precise, more sensitive, and we can compact the sensor. We'll be able to use these sensors broadly in an environmental setting.
Having made many different patents on different parts of the process and hundreds of copyrights, I was able to get into the quantum theory where there was packets of energy, an indeterminacy uncertainty principle. So everything becomes probability, and there's an entwinement or entanglement. Particles once joined have information exchange, and then there's an observer effect where the mind observes and affects things. The quantic mind can affect things slightly, and certain people can practice and get better at it. Life is quantic, and it's more like the casino than like a true binary computer, and only a fool thinks that he can totally control life. And studies show that the mind affects things mostly at the beginning of gambling and then at the very end of gambling. This keeps you coming back, as we can see from the money they make. We're able to prove the non-local universe in the books and the movies that I've done to show this possible. Here's a little bit of history.
Many millions of years ago, a race of hyper-intelligent, pan-dimensional beings got so fed up with the constant bickering about the meaning of life that they commissioned two of their brightest and best to design and build a stupendous supercomputer to calculate the answer to life, the universe, and everything.
Oh, Deep Thought, we want you to tell us the answer.
The answer to what?
The answer to life, the universe, everything. We'd really like an answer. Something simple.
I have to think about that. Return to this place in exactly 7.5 million years.
Is it finished? Oh, no, there's more. There's more. They go back.
What, 7.5 million years later?
That's right. They do.
Deep Thought, do you have
an answer for you? Yes, but you're not going to like it.
It doesn't matter, we must know it.
All right. The answer to the ultimate question of life, the universe, and everything is... $42.
42?
Yes, I thought it over quite thoroughly. It is, it's 42. It would have been simpler, of course, to have known what the actual question was.
But it was the question. The ultimate question. Of everything.
That's not a question. Only when you know the question will you know what the answer means.
Give us the ultimate question, then.
I can't. But there is one who can. A computer that will calculate the ultimate question. a computer of such infinite complexity that life itself will form part of its operational matrix. And you yourselves shall take on new, more primitive forms and go down into the computer to navigate its 10-million-year program. I shall design this computer for you, and it shall be called...
Starting with the EPFX, QXCI, SCIO, now the Eductor.
Every so often we find ourselves pondering the big questions about life. Why are we here? What's the meaning of life? The universe? Everything. Douglas Adams summed up the meaning of life, the universe, and everything to 42. Many have since pondered the significance of 42. Why 42? Some believe that 42 was nothing more than a random number. I have a different theory to share with you. Let's look at dice. Take a single die. It has 6 sides, and on those sides are marks to give each side its own number value. Let's add those up. 6 plus 5 plus 4 plus 3 plus 2 plus 1 equals 21. Let's add another die. What do you know? It's 42. 2 die equals 42. Therefore, the meaning to life, the universe, in everything, equals 2 die. A little depressing? I don't think so. But if you want more meaning, just consider this. It's just a roll of the dice.
Yes, the yes, no, maybe dice. The true random generator, which really is life. And you see, Niels Bohr thought that there was quantum probability. And Einstein said, God doesn't play dice with the universe. And I came along and said, you know, you're both right, because, see, God is the dice, and subspace is the table we play on. God had written a random number generator. You see, is it truly random? No, God is the dice, so it's not truly random. It appears to be. In this infinite, infinitesimal universe that's entwined and entangled, there's one level of subspace connection. And there's no such thing as noise, only information we do not understand. Starting with the EPFX, QXCI, SCIO, now the Eductor, we were able to make the world's first operative system. And this system, you have to understand, electrically, it works through an electrical interface. And only when the system's off, it doesn't detect another human being, does it actually go into this subspace connection, this, quote, type of radionics, but it's beyond radionics. And through this mass of the mathematics of what we are, quantum physics comes out. And it sounds like witchcraft. But no, this quantum physics is actually science. A lot of people have called me a witch, but actually I'm a scientist. And I try to bring all these things to you, not only in books and ideas and patents, but to try to bring all these things to you to help the body, as the SCIO and Eductor are entwined and entangled. They can give us information about the human patient, and they can treat the human patient. And thereby, they can help to create a whole new form of medicine. I hope that you understand a little bit more, and that you might want to get into the books and learn a little bit more and more about what we're doing. This is Desiree Dubonnet, having given you a little bit of information about quantum computers. Thank you.